All right, let's get started. Hey, we all made it through to the last class. That's good. Remember that your PS11 is due tomorrow or Friday with a late day. Classes end Thursday. Friday is reading day, so the TAs will not be holding their usual consulting hours on Friday. So if you need help, go get that help Thursday. Yes? Yeah, if you had a late day when you started PS11, you can hand it in Friday. Okay. We brought with us all of the cheat sheets that we still have for the midterm. If any of you still want them, you can see us as soon as we have time to lay them out in alphabetical order. They're alphabetized, right? Yes. So we'll try to get them out at the break. And remember, the final is a week from today. It's for the regular section. It's either in here or upstairs, depending on your last name. And it's from 3:30 to 5:30. For the hybrid section, it's here from 6 to 8. Okay. So what I asked you to do was figure out if you had any questions as far as, well, I'll take questions about PS11, questions about the final, the course. Yes? Okay, so what you're saying is your alien ship every now and then just doubles the speed out of the blue? Okay. That sound familiar to anyone? Anyone have things suddenly speed up? What occurs to me is that if you called move twice as often, then it would go twice as fast. But you're sure you're not calling move? Okay. I'd be happy to take a look at it later if you got time. Yeah?
I think there was something on Piazza about that, if I recall.
He's saying there's something on Piazza about that. So, yeah?
I have a question. With the alien ship, it's supposed to spawn every 5 to 10 seconds, level 2 and higher. Should it still spawn if you're in like the death animation? So if the ship is destroyed and like the debris is like flying around, can it still spawn during that, or should we reset the timer?
That's a really fine point. So the question is, the alien ship is supposed to spawn 5 to 10 seconds from the beginning of the level, and then after it's destroyed. Should it spawn when there's debris floating around? Any reasonable decision is fine. Yeah?
Can you go over what kind of questions we can expect about typecasting?
Okay, so he asked what kind of questions to expect about typecasting. Okay? Let's talk about typecasting. What kinds of typecasting are there? Where do you see typecasting? Yeah? Say it a little louder. Okay, so wrapper classes, they don't actually do typecasting. It's just they automatically box and unbox things. That's sort of a different thing. So typecasting is when you do something like this. So the typecast is when before an expression, you put a type in parentheses like that. That's called a typecast. And what does that particular typecast do? Yeah. Well, suppose x is a double. Suppose we got a double x up. Clear? Yeah? Okay, so right, this type of typecasting, when you're casting primitive numerical values around, actually does a conversion. So it would take this float, let's say the float is 3.14, and when you cast from a float or a double to an int, it just truncates it, doesn't round it, just truncates it. So that would store a 3 into n. So that's an example of a typecast that actually does a conversion. But that only applies to primitive numeric types. What's the other kind of typecast you see that actually doesn't do a conversion? Yeah?
Typecasting an object.
Okay, so typecasting an object. So let's say that you have, you try to do this. You declare x to be a new a, and then we do something like this. Okay, that's an example of a typecast. Except, scratch that. I want to cast it to B. Okay? Who knows what that does? When does it succeed and when does it fail? Those are kinds of questions I can see asking. Okay?
It'll be valid if B extends A, and then it'll be useful if B has some methods that A doesn't that you want to use on that object.
Okay? So the idea would be this will do no conversion. It's just checking to make sure that this x, whatever is in x, is compatible with B. Okay? And let's draw a picture. Suppose we have A which extends B which extends A. So let me write it this way. Suppose B extends A. Will this cast succeed? So X contains an A object, and B is extends A. Right. That will not succeed. But if it's the other direction, if we have what about if we have that A extends B? What's the difference there? Why does that succeed? Yeah?
B is going to have every method and property, so to speak, of A, but not the reverse.
Okay, you said B is... Say that again.
So B is going to have every method and property, so to speak, that A has, but the reverse is not true.
It's the other way around. A is extending B. So A is going to have every method that B has, plus possibly some others. Okay? So if X is an object of type A and we cast it to type B, it's safe because A has every method that B has. So A can do everything. An object of type A can do everything you expect an object of type B to do, plus more. Okay? Is it necessary to cast in that situation? Or can we just do that? Sometimes it will automatically cast things without us asking. Is this a situation? Let's make it more concrete. We say A extends B, so let's make it let's make it ship extends participant. Makes it easier to hold in your head what's going on. So ship extends participant, and we have a ship that we'll call S, and we want to have a participant P. Would you expect that to work? You have a ship variable, you have a participant variable, can you store a ship object in it? Yes, because a ship is a participant. And in fact, no cast is required. Yeah?
So going back, you said that in the first example, it's actually converted. It's not actually changing the value of x. Like if
Well,
later on down the road, if I wanted to refer back to x, it would still
right.
have 3.14.
This here does not change the value of x. What it changes is it changes a 3.14 into a 3 and stores it in. It doesn't change what's in x, but it changes the value being cast. When we do this assignment, if we say p gets s, there's no conversion being done. It's just the reference is being stored into the p variable because that's fine, because a ship can do what a ship is a participant, so that's fine. On the other hand, if you tried to say ship s gets some p, that's not allowed because the compiler can't necessarily tell if P is a ship. It could be like an alien ship, or it could be an asteroid. You can't. That's not a kind of ship. Yeah.
So P is a participant object and couldn't call any methods that are in S that aren't in P.
Right, and in fact, won't get the chance because you just can't do that. Right. There may be methods on ships that aren't supplied by a participant object. So that's why.
In the one that you have boxed there.
Oh, up here?
Yeah, you could not call any methods that are in S that are not part of P.
So once you take S, you take a ship object and store it in a participant variable. All you can treat it as you have to treat it as a participant.
Unless you cast it back to a ship.
Yeah, unless you cast it back. Okay. Now, what about this? That's a cast in action there. What does that cast do where we say ship S equals cast P to ship? So P holds a participant. We're attempting to cast it to ship and then store it in the variable S. Yeah?
Would you do that in a situation where you knew that P was already a ship, so that would just get that cast to Java?
Yep, exactly. So what he's saying is, if you happen to know that P contains a ship object, because you just put it there, what you're asking at runtime, what's going to happen is that Java will check to see whether that thing really is a ship object, and if it is, then it will store it to S. If it isn't, it will throw an exception. So this first cast, where we went from this one here, that's upcasting. That always works. The other form is downcasting, and a check is required. Now, what if you have a ship class and then it's extended, so there's an alien ship class and a regular ship class. Okay, so you've got this tree where you've got a participant class, it's extended by a ship class, and then there is a regular ship class and an alien ship class. Could you store an alien ship object in a ship variable? If you had an alien ship, could you store it in a ship variable, given this inheritance picture here? Well, you let me store a ship into a participant. So is an alien ship a kind of ship?
Yes.
So you can store alien ships into ship variables. Could you store an alien ship into a participant variable?
Yes.
Yeah, because it's transitive. Could you store an alien ship into a regular ship variable?
No.
No, because they're not related that way. Yeah?
Is there any way to cast earlier than this or like if you cast it?
No, there's no way to cast from RS to AS. There has to be a subtype relationship. Now, suppose you had an array of ship objects. And you knew that some of them were regular ships and some were alien ships. And you wanted to go loop through the array and do one thing if they were alien ships and do another thing if they're regular ships. How can you find out what kind of object you're dealing with? Yeah? Let me get in.
Just use of alien ship then, and then else do something else.
Okay. So let me make some room here. It's not the best eraser. Okay. Okay, so what we can do is in a loop we could test. We could say ships sub I instance of regular ship. So we could say if ship sub I instance of regular ship. So in that case, then now you've tested it's a regular ship. So you're safe in saying RS R equals regular ship. So that's a common kind of thing. When you want to, you've got a collection of things, you want to downcast them to a specific type. And you need to do a test. So you do the test with the instance of operator, and that tells you what you're dealing with. So then after we've done the cast, then we could say R dot and invoke methods that are special, particular to regular ships. So often downcasting goes hand in hand with the instance of test. Yeah?
Which one, so downcasting and upcasting. Upcasting is...
Okay, so if you made a graph of all the classes where object is at the root and deeper in the tree, so everything extends, things that extend object would be the children of object. So maybe P would be a child of object. The things that extend P are its children. Things that extend S are its children. So upcasting means going toward the root, toward object. Downcasting means going the opposite direction. Yeah?
So, I thought you said we can't downcast. So
You can't automatically downcast. Upcasting is done implicitly. You don't have to do put a cast into upcast. You can store a ship in a participant variable regardless.
So there is a scenario when you could store a participant as a ship, cast into a ship.
You can't store a participant object into a ship variable, but you can store an object contained by a participant variable into a ship variable, if that object happens to be a ship. See, if we have a participant variable, we could store a regular ship, an alien ship, a ship, or a participant into that variable. If we wanted to turn around and treat it like it's an alien ship, we'd have to do the cast, because that variable may not contain an alien ship right now. It may contain a regular ship. We don't know. So to downcast, you usually test it and then do the downcast. Yeah?
Okay, so if you have a ship stored in a participant variable, and then you invoke overridden methods that are in ship on that, will it invoke the overridden methods? Or?
Okay, so his question is, you have a ship stored in a participant variable, and you invoke a method that the ship class overrode. Which method do you get? The original participant method or the overridden one?
Depends on whether you downcast first.
Okay, I've got an answer that it depends on whether it's downcast, but that's not actually true. It has nothing to do with casting. That's not what I thought it would do. Go to a new page, but I'm just going to heck with it. Okay, let's look at it this way. So let's say we have a participant class, and it has a method void f, and what it does is print. It does that. Okay? And suppose we have a ship class, and it overrides that method and prints ship. Okay, that's the scenario we were asked about. Okay? So we do this. Participant P equals new ship. P dot print. What is printed? Part or ship? And is your answer any different if we do this? What if we cast P to a ship and then call print. So we do a downcast followed by a print method. Yeah, what happens? Yeah. The thing stored in P is a ship object. When you ask the ship to print, it runs its own code. So it's going to print out ship. It'll print out ship in either case. Doesn't matter whether you cast it first or not. And that's important. How would your asteroids game work if when you take, okay, so I have code that I wrote that every frame refresh, I go and find out the shape. I call the shape method on all the participants. Find out what the shape is and draw it on the screen. Okay? Every class in there, every ship, bullet, and so on is overridden that get shape method. What would happen if, when I called, if I have a list of these participant objects. So what I have internally is an array list of participants. And I iterate through this list, and for each participant, I call its get shape method. Okay? So those participants are stored in a participant variable. What would happen if, when I called the get shape method, in this context here, I got the original get shape method from participant as opposed to the overridden ones in the other classes? What would be drawn on the screen? Well, you wouldn't see a ship, you wouldn't see an asteroid, you wouldn't see a bullet. You'd see nothing because the method you're overriding, get shape, doesn't do anything, doesn't return it. It returns an empty shape or something. So this is absolutely crucial. It doesn't matter, when a method is called on an object, it doesn't matter where it's stored currently, what type of variable it's in, what type of list it's in. It just depends what type of object is it. It was created with a call to a constructor. What was the constructor? And that determines which methods are available. Yeah?
So if you upcast it, will it still print ship? Like if you do participant P dot print?
Now, if you do participant P dot print, you haven't changed anything about the object. So it still prints ship. It's still a ship. So this type of casting only has to do with determining when the program is compiled whether it's safe to store objects in certain contexts. But when they're actually used at runtime, it doesn't matter what context you're using it in. The object has an identity and it prints. I mean, it does its overridden method. Yeah?
So I thought I understood this, but I think I'm confused. So if there is a method in ship at this point, since we stored it in a participant variable, can I still call the method that doesn't exist?
Okay. So what he's asking is, we do this, and then let's suppose there's some method that we've added to the ship that is not a participant. Let's say it's H. Can we say, after we've done that, can we call that method p.h?
Yes.
Okay? The ship is stored in a participant variable. Okay? I've got a yes. Any other opinions? Yeah?
You'll need to cast it first, or else you'll get an error.
Yeah. The answer is no. Okay? The compiler determines which method you're allowed to call. That's determined by context at compile time. So the compiler says, okay, P is a participant variable. I don't know. It could be a participant object. It could be a ship object. It could be an alien ship object. I don't know for sure. I'm not going to allow it. Okay? So the methods you're allowed to call are determined by context. What happens, and that's done at compile time. The method what happens when you call the method is determined at runtime by the type of object it is. Okay, well, we've been on this for a long time. Thanks for asking the question. I think it'll come up again when we look at the sample exam. any other questions I could answer? Yeah.
Can you go over the question mark thing?
Okay.
I've never seen that before yesterday.
Question mark operator.
Okay, there's something called the ternary expression. I don't know that I even assigned any reading about it. Did I?
That makes sense.
Okay? So it's a conditional, except it's an expression. So the way it works is you give a condition like x greater than y. Then there's a question mark. Then there's another expression. Then there's a colon. Then there's another expression. So that there is an expression. So it has a value. And the way the value is determined is this expression here is evaluated. That has to be a Boolean expression. If it's true, the value of the entire expression is the value of that. And if it's false, it's the value of that. So what would happen if you did this? What would you say that statement right there does? It's storing something in M. It's either, yeah.
It's the max.
Right. It computes the max of x and y and stores it in M. Now, people have different opinions about ternary expressions. It took me about 35 years to warm up to it. I avoided it like the plague until a few years ago. But I like the fact that there are, it sometimes allows you to avoid doing something like this. If x greater than y, m equals x, else m equals y. That's complicated. It's just a lot to write when you can just write it like this. On the other hand, they look kind of weird. That's why it took me so long. So I use them. A lot of times I'll use them to return. So instead of saying if some condition, return one thing, return the other, I'll just say return. Say I want to return the max. I just say return x greater than y, x, y. So that's the ternary expression. Other questions? Yeah?
Could you give us an explanation just like on the basics of recursion?
Okay, he wants an explanation for the basics of recursion. Well, in many ways, I think it's unfortunate that recursion has a special name. Recursion is just method call. Right? If you have a method f, and somewhere in here you call f something different. The way to think about it is it's just you're just calling a method f. It happens to be the same method, but it doesn't really matter. You just, like any other method call you make inside of a method, you're expecting it to behave according to its specification. Okay? Now, in practice, most recursive methods are going to have a base case and a recursive case. So you're going to see something like this. If n is 1, return 1, else return n plus f of n minus 1, let's say. So let's trace through what happens when this method is called. And let's say we call f of 4. Okay? We know we have a runtime stack, and there'll be a frame created, and in that frame we're going to store n, and n is 4. So this call to f of 4, it's got that stack frame on the stack. What happens when we recursively call f of 3? Right, it pushes a new stack frame, and n is 3. Then we call another recursive call, n is 2. Another recursive call, n is 1. So at that point, this is the active stack frame. These guys are just waiting their turn down here to be exposed. We're only looking at the topmost stack frame. And so we run our code against it. We say if n is 1, it is, we return 1. So we pop the stack frame. and return 1 to whoever called us. What's that method going to do? Well, it's executing along. It's going to look at the top stack frame and say, oh, is n 2? No. So I got to return n plus f of n minus 1. Well, actually, it was already at that point. F of n minus 1 was 1, so it adds 1 to 2 and returns 3. So stack frame is popped. Now we're back at this invocation of the method here. It's just find out that f of 2 is 3, and it adds that to the 3 that's on the stack. It gets a 6, returns it, and so on. So that's what it looks like in memory. As you do deep recursion, the stack grows. As you return, it shrinks. But you need to think about recursion as just another form, just a way to make a method call. Yeah?
So I'm confused with like what the n plus f of n minus 1 does, because couldn't you just do f of n minus 1 and wouldn't it be the same thing? Because aren't you just like subtracting from it each time until you get to 1? Or until
Well,
n equals 1?
first of all, what does this method do? What does it return? You pass it 4. So it's going to give you back. What would the Java doc say? What's it return? Yeah?
It's sort of like an addition factorial.
You said like an addition factorial. That's pretty good. So what it returns is, it returns the sum 1 plus 2 up to n. It sums up the first n integers. Okay? So what if we took out the n plus? What if we just said return f of n minus 1? You call f of 4, it calls f of 3, it calls f of 2, it calls f of 1, that returns 1.
Just return 1.
Right, returns 1. So if we got rid of this n plus right here, we'd have a method that always returns 1. A very inefficient method that always returns 1. But the way to think about the recursion is, let's argue that this method does the right thing. It's supposed to add up the numbers from 1 to n. Okay? We got to look at this. What does this method call do? If you're reasoning about this program, what's your thought process? You look at f of n minus 1, what do you think? Do you think that's going to call f of n minus 2, which will call f of n minus 3, and so on? No. Think about it like any other method call. So what would your argument be? Yeah?
Returns the sum of all the numbers from 1 to n minus 1.
Right. The Java doc says that this call right here is going to return the sum of the integers from 1 to n minus 1. We add n to that, and now we have the sum of the integers from 1 to n. So we're returning the right thing. Yeah?
I'm just kind of confused because you passed in 4, but the next value you get is 3, like as you show the stack. So that's why I was kind of confused.
Sure. F of 4, F of 3, F of 2, F of 1. Now, what does this method call return? When you call f of 1, what does it return? Not a hard question. 1. Okay? What does f of 2 return? If f of 1 returns 1, what does f of 2 return? F of 2, n will be 2. It returns 2 plus f of 1, which I said was 1. So that's 3. F of 3 is going to return 3 plus f of 2. That's 6. F of 4 is going to return 4 plus f of 3, which I said was 6. It returns 10. What's missing from the stack diagram are the return values. Yeah?
Just a clarification, you said that it returns the sum, but then you had it void.
Oh, yeah. That's what happens when I write programs this way. Thank you. Someone make me a compiler that will compile my...
Is it even possible to have a recursive function that returns nothing, like it's void?
Yeah, you could have a recursive function that returns nothing. If it, for example, I have an example I sometimes use that draws a Sierpinski triangle.
Okay.
So the recursive calls are drawing fractals. They're not.
Okay.
Yeah. All right. Any other questions? Yeah.
Can you explain why these lists are better for insertion?
Okay, so why are linked lists better for insertion? All right, let's think about that. So let's compare inserting into an array versus inserting to a linked list. So here is an array. 1, 3, 2. Let's say 1, 3, 4, 5, 6, 7, 8. And I'll even give you room to grow. What's it going to take to insert a 2 between the 1 and the 3? What will we have to do? I want the array to end up just like it is, except there's a 2 between the 1 and the 3. Yeah? Right. I've got to copy the 8 to there. Then I got to copy the 7 to here. Then I got to copy the 6. I got to copy the 5. I got to copy the 4. Never done this before. I got to copy that 3. And finally, we've made room to insert the 2. So the amount of work that's required depends on the length of the array. It wasn't too bad in this case, but if the array were 1,000,000 elements long, that'd be a lot of copying to do to make room for the new element. So that's one. Now what about if this is a situation? So we have a linked list. And I'm not going to draw anymore, but so there's our linked list. What does it take to insert?
Just a question when you get ready.
What's it take to insert into this spot, the 2 right there? What do we have to do? Yeah? Okay. So we've got to create a new link. We'll store a 2 in it. This link will be the same as the link that 1 currently contains. And then we've got to go and get rid of that link and do it there. And it doesn't matter how long this list is. It takes the same number of operations to do the insertion, no matter how long the list is. Yeah?
So given that linked lists aren't indexed, how does Java know where to insert as well?
Okay, now you've hit upon a key question. My argument that it's more efficient to insert into a linked list assumes that you're already at this point where you want to do the insertion. I cleverly chose to insert after the first element, so it wouldn't be an issue. Clearly, if you've got a 1,000,000 element array, linked list, and you say insert into the middle, first you've got to traverse the list. Then when you get there, it's fast to insert. So it's a little more complex than I let on. A little more subtle, I should say. Okay, Stefan got a question from a viewer.
It's not about this. It just says, well, first comment is CS is fun.
Okay.
And then the person asks, can we go over part C on the final?
Part C. Okay, yeah, well, I have a sample final to go over. I assume I will. But let me see what other questions I've got first. Yeah?
Are you going to upload the second sample file and answers?
Yes, it's in the final itself is in the schedule right now. I'll put the solutions up later. Yeah?
The difference between extending a class and implementing a class?
Okay, he wants the difference between extending a class and implementing a class. Well, there's a problem with your question. You extend a class. You do not implement a class, you implement an interface. Okay? Now, what do they have in common? What do extending and implementing have in common? What'd you say?
Are they both forms of inheritance, technically?
Technically, usually you talk about extending as being inheritance. Yeah?
Methods?
Well, they all involve methods, sure, but okay? They're both ways of doing subclassing. So remember that picture I drew that had a participant class? We extended it to get a ship class. We extended that to get an alien ship class and extended that to get an RS class. Okay? That set up a subtype relationship. S is a subtype of P. AS is a subtype of S. Now, what if P had been an interface? And we implemented the interface to get S, and then we extended S to get AS and RS. Would that still be a valid picture? We know that S is a subclass of P if S extends P. Is S a subtype of P if S implements P? And the answer is yes. Exactly the same considerations apply there. The difference is that with inheritance, with extending, you inherit a bunch of implementations of methods. When you implement a class, all you do is inherit the obligation to implement some methods. You don't actually get any code. So you have to provide the implementations. Now, that's sort of a compromise in Java. Some languages, like C++, you can have a class A and a class B, and you can inherit from both. So imagine C extending both A and B. So you get the methods from A and the methods from B, and the instance variables from A and the instance variables from B. Can you see what could go wrong or be confusing if you did that?
Yeah.
So what?
If like A and B conflict somehow, like if they
Right.
have like the same instance variable.
Right. What happens if A and B have two methods with the same name that do different things? What's supposed to happen? And so there are these complicated rules in C++ to say what happens. So in Java, to avoid that, you can only extend one class. That's where you actually get implemented methods and instance variables from. But you can implement many interfaces because there's no possibility for conflict. All you're getting is the obligation to implement things, not implemented things themselves. Yeah?
What about abstract classes?
Okay. So the question was about abstract classes. Well, an abstract class is just a class that contains one or more abstract methods. And when you extend an abstract class, you inherit the implemented methods, and you get the obligation to implement the abstract methods. So an abstract class is sort of like a cross between an interface and a class. Yeah?
What kind of thing can be defined as an event that can be listened by an event listener?
Okay, so the question is about events. So let's take like an action performed event. Okay? So could you rephrase your question in terms of action performed?
Okay, so there are two events that I'm familiar with. One is the mouse event, one is key event. But in yesterday's review, there are other events called timing event or collision event. I think that's not used in some common cases.
Yeah, so an event is just, I mean, you can dream up your own events. The important thing is if you, let's say a mouse event. The mouse can move, and you got to have some way of notifying the program has to be able to find out that the mouse moved. One model is that you write some code that just constantly looks at the mouse to see if it's moved. But that would be kind of difficult. So instead, the system does that for you, and when the mouse moves, it notifies anyone that was interested that it moved. And the way you say that you're interested is by registering yourself as a mouse motion listener. But there's nothing special about the mouse. We can have, there can be keyboard events. When windows get resized or expanded, you can cause an event to happen. So really all that matters is that there be something that you want to be able to tell other parts of your program about, and then you create a listener interface that users implement in order to find out about that event. Yeah?
I think I think what he was talking about is on the final that we had to review yesterday, part M says the question concerns the base implementation of asteroids that you gave us. Give 4 distinct ways in which event listeners were used in this implementation. And it's like technically we only use like the listener for the timer, and then the listener for the key events, and then the listener for the
okay, so there was a listener that dealt with the button, the new game button. We used a listener to find out when the key was pressed, when it was released. Yeah, basically we use a listener to do the frame refreshing. A lot of you are listening to a timer in order to do the background sounds.
So when it says give 4 distinct ways in which event listeners were used, would we just say like key up, key down?
Yeah, key up, key down, button pressed, timer went off. Yeah?
Could the collided with method, could that be considered an event?
So, yeah, essentially, collided with is an event. It's not handled with a listener object because I just built the listening method directly into participant class. But yes, I would call that an event. So that's an example. 2 objects colliding is an example of an event that happens that has nothing to do with the computer, with mice or keyboards. It's just something that I decided people would like to be notified about. So you don't have to write any code at all to check whether 2 things have collided. You just get told when they do. So it makes your job easier. Okay, let's move to the other exam. You're going to find out here that some of the questions are the same as the one that you looked at. So what do I have to do to make this work? Yeah, we've got so many questions, I'm just going to go straight through here. Okay, I think this one here was on the one you looked at yesterday, is that right?
And that 4th one is confusing.
Okay, say the 4th one is confusing. Okay, an index collection of integers that supports efficient insertion and deletion. Okay, so if you've got an index collection of integers, what are you talking about? Right, it's either an array list or a linked list. Those are the only 2 index collections we looked at.
Isn't a linked list technically not indexed, though?
No, okay. He said, is our linked list not technically indexed? They're definitely indexed. You can say get element 3. Indexing is inefficient,
Inefficient. Okay.
but it exists.
Okay.
But the question wasn't for efficient indexing, it was efficient insertion and deletion.
Right.
And so the answer would be linked list of integer. Okay, you saw that yesterday. Okay? Right here, what happens when the following 2 statements are executed? Yeah?
Null pointer exception.
Right, that's going to be a null pointer exception. Had it all set up to write. I think I click on that. Now, it's always bugged me that this exception is called that, null pointer exception. Can you guess why I don't like it? What's wrong with that word? What is null? Is null a null pointer? It's a null reference. The exception should be null reference exception. Pointer is an implementation detail, an address in memory. Okay? C is what someone asked about, so I'm glad we're here. What information is contained in a stack frame? Yeah? Okay, so the values of local variables and parameters. Now there are other things that are also stored like I briefly showed you, you can store the return address. So when you make a method call, you've got to record somewhere the address of the next instruction to be executed when the method call returns. That can be stored on the stack, but what I was interested in is getting that. The values of locals and parameters. There can also be temporary values in the stack frame and so on. Okay? Now, this test is from 2011. And since 2011, I've become more careful about making up tests to the point where when I want an answer to a question like that, I no longer give you a big blank space. I give you a box. And I try to make the box so that it can contain the answer and not much else. Because otherwise people will write a paragraph or a sentence will do. So what is the purpose of a layout manager? Got a graphical user interface. What's the purpose of a layout manager? Yeah? Yeah, it gives you a way to organize the components of a J-frame. So I'll write that here. Organize components of J-frame. Now, without a layout manager, you'd be stuck having to make all these detailed decisions about placement yourself in your code. But instead, with a layout manager, you just give it a strategy. Order these into a grid, or order these left to right, or top to bottom. And Swing takes care of the rest. Okay, this is related to what we were just talking about. Okay, so I is an interface, and A is a class. And we have classes A, B, C, and D, and you can see all the relationships right there. So, faced with this question, what would be a good thing to do besides diving in and answering it? I would suggest writing something on the exam other than in the box in this case. What diagram should you draw if you're faced with something like this? Yeah?
Kind of like a flowchart diagram for drawing.
Okay, you said the flowchart diagram. I call it more like a type hierarchy. Okay, so let's see. It says B extends A, so I'll draw A here and B extends it. I'll draw an arrow in the direction of extending. Okay, and then it says C is an object of class C which implements I. So I is an interface that's implemented by C. And then D both extends B and implements I, right? So I should have, I'm going to do this. Put C over here, and then we got D, which extends B and implements I. Okay? So when the question here is, are these method calls legal? And this picture lets you understand them. So is it okay to pass this first one? We do F of A and D. So what you have to ask is A type of A? Okay, the first parameter has to be of type A. Second parameter has to be of type I. So A is an object of type capital A, so surely it's okay to pass as that parameter. What about the D?
Yes.
Is an object of type D a kind of I? Yeah, this diagram tells us that. So that's good. Okay, can you pass a B where an A is expected?
Yes.
Yes. Can you pass an A where an I is expected?
No.
No. Okay. There's no relationship between the class A and the interface I. So you can't do that. Okay? Can you pass a C where an A is expected? No. C is not a kind of A. Can you pass a D where an A is expected? Yes. A D is a kind of B, a kind of A. That's good. And can you pass a C where an I is expected? Yes. Okay? If you don't draw the diagram first, then you're sort of you've got to reconstruct it in your head every time you answer a question. So if you can get the diagram down once, get it right, then you can answer. You can just read the answers off. Yeah.
Can I pass FD comma D?
Okay, D comma D? Sure. All right, so here's the question. Can you do this? F of D comma D. Okay, so we just ask, is D a kind of A? It is. And is D a kind of I? It is. So yes, you could do that. And it would be kind of interesting because inside the method, X and Y would actually refer to the same object. But there would be things you could do to X that you could not do to Y and vice versa, unless you did a cast. Okay? Any other questions about that one then? Okay. So I mumbled up here to Stefan. I was going to go straight through, but I'm going to change my mind because we have been at it for a while. Let's just take a break for a couple minutes, and we'll resume. So stand up and stretch or something. Okay, let's get started again. Okay, I just want to remind you the reason we brought all these cheat sheets back is because you can bring 2 to the final. So you might as well bring the one from the midterm. Okay. You always have a purpose when I ask a question. What's my purpose? What am I trying to find out if you understand when I ask that question? What aspect of Java did I have in mind? Yeah?
The skipping that happens when you have a hand,
determine.
Okay, so we said the skipping that happens, the word I would use is short circuit evaluation. So with an and, if the first expression is false, then there's no need to evaluate the next thing, right? Doesn't matter what the thing here turns out to be. If the first expression is false, the answer is false. And so Java doesn't bother with the second expression. So given that, what will happen if n is 0 here? Yeah? Oh, I thought you had. You can trust what you see. Is in, yeah?
Division by 0 exception?
Yeah, you're going to get division by 0 exception. Because, yeah, n is 0, that's true. That doesn't short circuit and. It only gets short circuit if it's false. So that's false, so it's going to evaluate this, and that'll require dividing by 0. So the answer is C. Now, what if I'd asked the same question, but with or? N is equal to 0, or 10 divided by n is less than 1. That would be true, and there the short circuiting pays off, because with false, if the first expression is true, then it's done. It doesn't look at the second one. Okay? So they short circuit in different ways. Okay? So generic types, like array list of string or linked list of double or whatever, is an example of which of the following aspects of object-oriented programming? Well, what is information hiding? What's that refer to? What does that sound like? The other thing about taking exams from 7 years ago is, the class is never exactly the same. So there could be things I stressed then I'm not stressing now. Yeah? Yes, private instance variables. So the information hiding is a principle. And the way we see that principle happen in a class is we make the representation private. We're hiding information from the outside world so that we can change it later on. So this is not example of generic, that's not information hiding. What's inheritance? That's when you extend. And this isn't an example of extension either. What's data abstraction? Yeah. Discarding what?
Unnecessary details.
Okay, well, that's abstraction in general, but what's specifically data abstraction? Do you have an answer? Say louder. You said commenting out stuff. Those are all examples of abstraction. Data abstraction is referring to what we do with classes. We create a new abstract data type when we create a class. Right? You create a cache list class, you've created a new type called cache list. And we think about it in terms of its specified behavior, not in terms of its implementation. So the answer to this one is B, parametric polymorphism. That's something I actually had on a slide somewhere. That's the parameter it's referring to right there. String, the array list is parameterized by the string type. All right, we've talked about that. The key difference between extending a class and implementing an interface. So when you extend a class, there's really only one thing you have to be sure to do to have a legal class. So if I got A and I extend it to create B, what do I have to put into B? So think about this. Class B extends A. Under what circumstances is that legal? Yeah. Say something about methods. Well, now that would be true for an interface. Okay? But with extension, there's no need to implement any interfaces unless you want to override or add. Yeah?
What they call the superconstructor?
Right, you've got to add unless if A has a constructor that takes no parameters, you're okay. Otherwise, you have to add a constructor here that calls the superconstructor, passes it some parameters. Okay? So extending is easy. When you implement, and you have a class that implements, let's say B implements A, what are you on the hook for? What code do you have to write? Yeah?
The method stuff for every method in A.
Right, you've got to implement, well, A is basically a list of method stubs. You've got to implement them. There is a way to get out of that job, though. You can add one word to this and get out of the task of implementing all of the things from A. Yeah? Well, we could, yeah, I could make B an interface instead of a class, but I meant, you could say class here. Actually, I'm not, now that I said it, I'm not sure. I think it would work just say abstract in front of it. Although, now that I think about it, it might require you to actually redeclare the stubs, I'm not sure. That's just an aside. What's garbage collection? That would just take a little box. Yeah.
Gets rid of the object data for variables and stuff that have no references.
Okay. So we know there's a stack. We've talked about the stack today. The stack often, if the value of a variable is an object, it'll have a reference to that object out in free memory in the heap. And garbage collection just refers to the fact that it's the process that finds objects that no longer have references to them from the stack, either directly or indirectly, and reclaims the memory for future use. Okay? So one of these statements is false. So you take a million element array, would you expect merge sort to win or selection sort to win? Which was faster? Yeah, merge sort's faster. So that's not the answer. Okay, and I showed you the code. Selection sort is iterative. It's two nested loops. Merge sort's recursive. You split the problem in half, solve the two problems recursively. So that's true. If selection sort takes 1 minute on an array of 1 million elements, it will take about 2 minutes on an array of 2 million.
That's false.
Hey, what was the rule? What did we discover when we experimented with selection sort? Yeah, we know it's an n-squared algorithm. And the characteristic of an n-squared algorithm is if you double the size of the problem, the running time quadruples. Okay, here's a coding problem. Returns the largest number in the non-empty array numbers. So that's what kind of loop? Yeah, that's an optimization loop. So it's going to look something like double D. So we'll sort of seed with the first element of numbers. That's the biggest we've seen so far. And then we could do something like for okay? So that's the sort of thing you really ought to be pretty good at by now. Just dashing off a loop to find the largest element in an array or any collection or whatever. Okay, boxing and unboxing. Where do we see boxing and unboxing? Yeah?
Wrapper classes.
Wrapper classes. So the deal is these generic types for historical reasons, can only be parameterized with object types. So you can't have an array list of ints. It has to be an array list of integer objects. So the difference between an integer and an integer object is, so an int would be something like 3. An integer object is just an object that contains a 3. And there are really only two interesting things about the integer class. There's a constructor that takes an int and creates an integer object. And there's a method that takes an integer object and gives you back the int it contains. So if you try to put an int into an integer list, Java will automatically take that int and do this to it. It'll create an object that contains it and store it in the list for you. And then when you ask to get the int out, it will automatically take that object and extract the int from it using the method I mentioned. So boxing that's the boxing part. And unboxing is the opposite direction, where you take the object and get the int or whatever. And that's all done automatically most of the time. Every now and then there'll be a situation where it isn't. It gets pretty confusing because you're so used to it always working transparently. Now, when you learn a language like C#, which is more sensible in this regard, you'll find that this whole thing disappears. C#, you can have an array list of ints. Yeah?
So what would be an appropriate for this?
I would say something like boxing refers to automatically taking a primitive type and creating a wrapper class, putting a wrapper object around it. Unboxing is taking the wrapped object and the wrapper object and removing the primitive value. All right, we already talked about that one. That was on the. And I can tell you, if you see a question like this, if say Stefan is grading it, he's always saying, "Joe, should I count this answer?" You know, if it was remotely plausible, I'll say yes. So it's not like there's just 4 correct answers and that's all we do. Yeah.
Does boxing refer to the automatic process of stuffing a primitive into a...
I guess technically boxing doesn't have to be automatic. Okay. So we could distinguish between automatic boxing and explicit boxing. In reality, people don't bother because it's automatic. Okay, I like this one. I want to know if this is an array of arrays. How do you know it's an array of arrays? All right, you got the clue is right here. To index it, you index it with an index, you get back another array, and you got to index it to get an actual element. Okay, I want to know if every row has the same length. Okay, so let's get the first row. How would you declare a variable that can hold a row of that array? What is a row of that array? It's an array of ints, right? So it'd look like this. Okay, that would pull out the first row. So now you have a reference to the row. The way the picture is, A looks like this. Every element in an array refers to an array like that. And then row is going to refer to that. Okay? Now it's just really a searching loop. You're searching for something that isn't the same length as row. So we could let's do it indexing this time. Okay, what do we do with each row? Yeah, we look and see if its length is different from row. So if a sub, ignore that thing. If a sub I dot length is not equal to row dot length, going to return false, because it's not rectangular. And if the loop ends, we did not find a problem, so return true. Well, that just takes a little knowledge about two-dimensional arrays. Yeah?
I have a question about the arrays. We have to worry about getting like whether the rows and columns correspond to X and Y coordinates mixed up.
Yeah, so he's asking about, you know, when you look at a two-dimensional array, one question is which are the rows and which are the columns? No, the answer to your question is no. But it's just a matter of your perspective. If you want to look at a two-dimensional array and assume that it's a bunch of columns that contain rows, that's fine. You just need to be consistent. It's not a property of Java. Okay, returns the number of distinct strings in the array S. So you got a bunch of strings, you want to know how many different ones there are. Like if they're all the same, we're going to return 1. If they're all different, then the length of the array will be the answer. So the answer is somewhere between those two extremes. But let me give you this hint. Anytime you got a collection and you want to know questions that have to do with whether the things in the collection are distinct or not, you should be thinking about a certain data structure. Who knows what that is? Yeah? A set. So the idea be, I'm short on time here, the idea would be just to create an empty set, hash set or tree set, doesn't matter, and then take all the elements in the array and stick them in the set, and then return the size of the set. So if everything's a duplicate, you end up with just one element in the set. Yeah?
In the implementation problems, are we going to have any recursive methods that we'll have to do?
Okay, so he's asking, will there be a question about implementing a recursive method? We'll see as soon as I make up the exam. That's a possibility. This one here, since I only have like 30 seconds left, we really almost did that in class when we talked about linked lists. So I don't have time to go over the rest of this, unfortunately. But I will. The exam is posted. I'll post the solutions right now. And good luck finishing your asteroids, and see you next Wednesday.